I talk, you don't talk, remember? It's the rule. Okay. So, we make sure we have an equal sign running down the left-hand side. Go check. Do you have equal signs? Make sure you have them. All right. Everyone's paying attention because everyone wants to do well on the unit exam if they want to replace a different marker. Okay. This is just a simplifying one. Simplifying one is GCF difference of squares, all the numerators, all the denominators. So I can take out a 4x. 12x squared divided by 4x is 3x. 8x divided by 4x is 2. And the 4 and the x are monomials because whatever you GCF out is a monomial. We're watching, right? Okay. The denominator, what can I take out of 6x cubed and 4x squared? A 2 and an x squared. 6x cubed take out of 2x squared is 3x. Minus 4x squared take out of 2x squared is 2. This 2x squared is a monomial. Because whatever you GCF out is a monomial. Okay, we go to standard around permissible values. We have x squared can equal 0, which is always just x can equal 0. Squared, cubed, 4. Table's listening, right? Yeah. And then we have 3x minus 2 equals 0, or can equal 0. 3x can equal 2. X can equal 2/3. Cancels. This one cancels off one of those, and this can cancel off a 2 from there because those are monomials. They don't have to match perfectly. So we're left with 2 over x. X can't equal 0 and 2/3. The next one is subtraction. What do you need when you have subtraction? Common denominator. I have a binomial, which is x plus 2. I can't take it out of GCF. I have one that's 2x minus 1. Can't take it out of GCF. So I have to multiply them by each other. So this one's getting multiplied by 2x minus 1. And this one's getting multiplied by x plus 2 because of the denominators. We distribute the numerators and we keep the denominators because they're already common. Putting them together does not make anything better. So we get 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. Negative 1 times 2x is negative 2x. Negative 1 times 1 is a positive 1. All over x plus 2, 2x minus 1. Not put together because it's already common. Minus. Then we have in this numerator, x times x is x squared. X times 2 is 2x. X times 2 is 2x. 2 times 2 is 4. All over x plus 2, 2x minus 1. There is no point to put these together, right? The denominators together. They are common already. Putting them together just makes them less simplified. All right. I did give you a subtraction because you have to remember to subtract everything behind it. If you forget to do that, the answer to you forgetting that will be there as a multiple choice answer, right? Subtract all the term behind. Put it away. So we get 4x squared minus 2x plus 1 minus x squared minus 2x minus 4 all over x plus 2, 2x minus 1. Then we collect like terms. 4x squared minus x squared is 3x squared. Negative 2x minus 2x is negative 4x minus 6x minus 8x. And then 1 minus 4 is negative 3. X plus 2x minus 1. And I won't make you factor it further, especially with this thing one. All right. Because that one could actually factor. Okay. Then 3 is multiplication. Multiplication, we take out GCFs, different squares, all the numerators, all the denominators, right? Same 2 rules. Adding, subtracting is common denominator and solving. The rest is GCF difference of squares everywhere. So I get 6, y minus 5. Shh. All right. 1 minus y. If I rewrite it in order, it would be negative y plus 1. And then here I take out a 5, and I'm left with y minus 1. take out a 3y, and I'm left with y minus 5. So my non-permissible values are going to be y can't equal 1 from that one, 0 and 5. So these cancel. And then the negative y plus 1 and the positive y minus 1, can they cancel? Currently? No, they're the exact same but wrong sign. So what do I have to do? Take out a negative 1. And I'm left with y minus 1. Then these can cancel. So I'm left with 30 over negative 3y. And then I can take a 3 out of both, bless you. You take a negative 3 out of both, actually. This will become a 1, that'll become a negative 10. And so we get negative 10 over y. Y can't equal negative 10 over y. Y can't equal 1, 0, and 5. Okay, we're going back to our polynomial notes. These linear, if I gave you, let's say y equals 3x plus 6, this is linear and degree 1, right? Because the largest exponent is 1. What is this? The constant, what is it? Y-intercept, always, yeah. So it would be at 0, 6. And then what is this leading coefficient? The leading coefficient is positive 3. It's printing the other stuff and it's positive something. Leading coefficient is positive 3. What does that tell me about it? The graph is what? Up on the right, and because it's degree 1, an odd function, it discos, so it's down on the left, right? So this graph would be the slope would be something like this. Yeah? And we talked about cubics. Cubics can have a max and a min, or a point of inflection, but not both, right? So the max and the min on a cubic can go like this, or it can have just that point of inflection that runs through it, which is no max or mins, no turning points. Max and mins are turning points. So this one would have 2 turning points, this would have none. Yes? Both of these would have a what leading coefficient? Positive or negative? Positive, because it's up on the right. So this would be a positive leading coefficient, this would be a positive leading coefficient. We agree? If I give you this graph, and I gave you y equals ax cubed plus bx squared plus cx plus d, is a greater than 0 or less than 0? It's greater than 0 because it's up on the right, so my leading coefficient would be positive. We agree? Is d greater than 0 or less than 0? What is d? D is the constant, and the constant is the what? The y-intercept, yes? So, is d greater than 0 or less than 0? Greater. Right? To a degree? How many turning points does this graph have? A max and a min, so it has 2 turning points. Definition of turning point is a max or min. So that one is 2. This one here would have none. Okay? The domain and range of both of these, linear and cubic, so degree 1 and degree 3, are XCR and YR because they disco. Anytime it discos, we have all the X's in the world and all the Y's in the world. Okay? Then we're going back to quadratics from grade 11. So here we are, quadratic function. So we're going to look at 3 of them. The first one we're going to look at is y equals x squared minus 3x minus 4. Type it into your calculator. Go. Where's my calculator? Okay. Make sure your phone stays. Okay. So let's discuss this one. What is the leading coefficient of it? It's a 1. It's what's in front of my largest degree. It's degree 2, correct? So my leading coefficient is positive 1. So I'm suspecting this graph is what on the right? It's up on the right. What's it going to be on the left? Up. It's a degree 2. Even degree functions end in the same direction. They don't disco. So evens make parabolas. Like we talked about this last year, quadratics, they're both up or they're both down, correct? And on your screen, they're both up, yes? Which means this one has a minimum, yeah? So what is the minimum? Go find that minimum. Go use your calculator. Everyone find it. Write it down. So second trace minimum, left bound of the minimum, enter. Right bound of the minimum, enter. And I get 1.5 and negative 6.25. You will only have to find your max and mins using your calculator. There will no algebraic process to have to do that. 120-1 last year, you had to complete the square. You don't have to do that here. So, how many x-intercepts do I have? Look on your calculator. 2. They are specifically at negative 1, 0, and 4, 0, but did I ask for that? I asked for the number of them. So your answer would be 2, right? If I wanted to just quickly sketch this, this would be a really crappy sketch, but if I wanted you to actually graph it better, 1, 2, 3, 4, 5, 6, 7, 8, you would put more points on this than just these 3, right? Where would I get more points from? Table of values. Or second trace value, x equals 1, 2, 3, 4, right? And you get y out. So I did a very fast sketch. What is my y-intercept on this equation? Negative 4. Remember, it's the key thing is this has to be in standard form, so no brackets, right? Then my constant, the number without a variable, is my y-intercept. So my y-intercept is at 0 and negative 4. Do you agree? Okay, this graph is not discoing, yes? When it discos, it's XER, YER. This one doesn't disco. It's a quadratic, so what's its domain? If it keeps going out for life. X is element of the reals. So our domain for every quadratic, unless it's a word problem, is X and element of the reals. So actually, for a linear, a cubic, and a quadratic, a degree 1, a degree 3, a degree 2, so is XER. Because even if it discos or it goes out for life, correct? The catch with a quadratic, though, is my range is not YER, because it's where the graph exists. So I know that this minimum is at 1.5 and negative 6.25. So what's the lowest y that this graph goes to? Negative 6.25. 1.5 is lovely, it's max of symmetry, but it doesn't actually help me with my range because my range is just y values, yes? So is my graph above negative 6.25 or does my graph exist below negative 6.25? Above. So when I go to do my range, it's going to be y such that, squiggly brackets means a set of y values such that y is greater than, and it's equal to, because that's where it exists, correct? Greater than or equal to negative 6.25, because there's no graph below that. That's what you're telling me when you're giving me the range. You're saying the graph exists at negative 6.25 and above, yes? That's why when the graph is concave down and you have a maximum, it exists at whatever that maximum is and below, right? Because we're just saying where the graph is. Make sense? All right. I'm going to give you 2 more and you're going to answer the questions. Second one, so I want you to do this one and you'll do a quick sketch, not an accurate, it doesn't have to be perfectly accurate. Just sketching to help yourself out. That one. And your other one is this. So this one, the leading coefficient is -2. So I know it's down on the right, because that's what the negative tells me. And it's also down on the left because it's an even degree. Correct? They go in the same direction. My y-intercept is the constant at the back, so it's 0 and -5. How many x-intercepts does this one have? 0. Remember that degree 1 and degree 3, odd polynomial degree functions, will have for sure a minimum of 1 x-intercept because they disco. At some point in time, they have to cross through, right? Degree 1 and degree 3 at minimum will have 1 x-intercept. But degree 2 could have no x-intercepts. It could be completely above or completely below. Okay? This one's completely below. I need to find this maximum first. It's maximum because it's a hill. So it's the maximum that you can go. It means your entire graph is below it. The maximum is at 0.75, comma -3.875. The domain is XCR because it is for all polynomial functions. And the range, this graph is a maximum, right? So the entire graph is below that value. Yes? What is the value that it's below? Remember, range is y. So it's 0.75 or -3.875. This one, right? Because our ranges are y. Yes? And the highest it goes to is -3.875. So my range is going to be y such that y is less than or equal to -3.875. Y is now in the real. Okay. I'll come back to that in a second. The other equation is 3x squared minus 12x plus 12. When we type it in, it's tangent with the x-axis, which means it literally touches the x-axis and bounces. It has 2 of the exact same x-intercept. So the number of x-intercepts is 1. This one has a leading coefficient of +3. So if it's +3, we know it's up on the right, because it tells you how it ends on the right, but it's also up on the left because it's degree 2. It's even. They're the same direction. Yes? Degree 1 and degree 2 disco. Degree 1 and degree 3 disco. Degree 2 is either concave up or concave down. Okay. The y-intercept is my constant. What's my constant? 12. So it's 0, 12. Then I need the minimum, which is at 0, nope, 2 and 0, sorry. Which is actually the x-intercept. So my domain is x such that x is now in the reals. And my range, sadly, a lot of people will tell me x or y is greater than or equal to 2. But if you look at the graph, it's not greater than or equal to 2. That's the actual x value, correct? What is it greater than or equal to? 0, the y value, the minimum, yeah? So it's going to be y such that y is greater than or equal to 0. Y is now in the real. Okay? So we've talked about degree 1, degree 2, degree 3, linear, quadratic, cubic. Cubic is the only new one. And it can have 2 turning points, which is a max and a min, or no turning points, a point and inflection. Okay? The degree 1 and the degree 3 have a minimum of 1 x-intercept. Degree 2 has a minimum of no x-intercepts. Make sure you're paying attention because I'm summing it up. What is the maximum number of x-intercepts? It's equal to the degree. If it's degree 1, you can have a max 1 x-intercept. If it's degree 2, you can have a max 2. It's degree 3, you can have it max 3. I'm going to do a little summary up here. So degree 1, number of x-intercepts, how many can it have? 1, that is it. Its lowest is 1. Its lowest is 1 because it's degree 1. It discos, so its lowest is 1. And its highest is 1 because it's degree 1. Degree 2, what are the possible number of x-intercepts? What's the lowest I could have? 0. What's the highest I could have? 2 because of the degree. And you can always have the varying number in between. So what's in between? 1 is also an option. And then degree 3, number of x-intercepts. What's the lowest number degree 3 can have? 1 because it discos, right? It's going to have to go through at some point. What's the highest it could have? 3 because of the degree. And varying in between? 2. So the only one that can have 0 for you guys is degree 2. The other ones can have to have 1 for sure because they have to cross. Whereas degree 2 is in the same direction, right? So it can be completely below the x-axis or completely above. All right, we're going to bypass this, and we're going to go here. Match each. Try and not use your calculator. So we're going to use our leading coefficient to tell us if it ends up on the right or left, the degree, and the y-intercept. Okay? So try and match them without your calculator. So we have 2 linear ones. Both of these have negative leading coefficients. Where the heck is the other one? Here. So that means they're down on the right, correct? But then we can look at their y-intercepts. This one has a negative 3 y-intercept, so this matches, is that an h? We'll say it's an h. And then this one has a negative 3. Oh, crud, they're both negative 3. How do we know the difference? Look at their slopes, yes? All right. Let's try again. So if we look at their slopes, this one has a slope of negative 1 over 2. So I'm going to, remember, I rise before I run. So I'm going to go down 1, right 2. So I go down 1, right 2. I go down 1, right 2. So this one is h of x. And this one's down 2, right 1. Down 2, right 1. So this one is q of x. Sometimes you need to use the slope. You also could plug in your calculator. All right, I told you to try not to. Then we go to our quadratics. Both of these have leading coefficients of 1. They're both up and to the right. Cool. This one is a negative 2 is a y-intercept, so it's going to match this one, which is j of x. This one has a positive 1. It's going to match this one, which is k of x. And then we have our cubics. This one is concave. This one ends down on the right, so it's going to be this one. And let's verify it because it has a negative 2 y-intercept. Yeah. This one's g of x. And then this one is up on the right, negative 2 y-intercept. So this one's p of x. Yeah? So we use the leading coefficient and the y-intercept to get our graphs. All right. Let's look at these ones. So this one is negative cubic function, so it's going to end down on the right with a positive 4 y-intercept. So down on the right, positive 4 y-intercept. So this one matches 1. This one is positive leading coefficient, positive 4, so it's up on the right, positive 4. So this one matches 2. This one is a negative leading coefficient, positive 3. It's a negative leading coefficient, positive 3. So they both end down on the right. We're going to have to turn to our slope because the y-intercepts are the same. This one is down 2, right 1. So I'm going to go down 2, 1, 2, right 1. Nope. This one I'm going to go down 2, 1, 2, right 1. So this one matches that one. This one is down 1, right 1. So down 1, right 1 is here. So that's 5. Then we go to our quadratics. Why did I put a 2 there? This is squared. People, no one commented? Oh. This one's a square. This one matches this one. Cute. Sorry. Okay, this is the squared and this is the squared. If I expand this one out, it's x squared plus 3x plus 2. So this one has a y-intercept of 4. This one has a y-intercept of 2. So y-intercept of 4, so this matches 2. Y-intercept of 2, so this matches. And you're going to flip over. Okay. So here you're going to use technology and you're going to answer these questions. And then here you're going to determine the degree of the leading coefficient of the constant term. And then I want you to do 4. So I want you to do 1, 2, and 4. Go. Their homework.